So let's start with multiple choice questions and exercises for chapter 3. For the multiple choice questions, we start with the first one. The mean of a sample is computed by summing all the data values and dividing the sum by the number of items. The notation X bar usually refers to the, of course, this is your sample mean. Which of the following is not a measure of central location? This would be your variance. Another term for average is mean. The Greek letter mu usually refers to the population mean. We mentioned before that Greek letters are used for population parameters, for population measurements. So any measurement that derives from a population, we use Greek letters to represent them. Number 6, the middle value in an ordered array of numbers is, as we all know by now, the median. Which of the following is a measure of dispersion? A measure of dispersion would be variance. The difference between the largest and the smallest data value is the range. The standard deviation of a sample of 100 observations equals to 36. The variance of the sample equals to what? So we have a sample size that's 100, and we have a standard deviation, that means S is equal to 36. I have S and I'm looking for S squared. All you need to do is square your standard deviation in order to find your variance. So in this case, the correct answer will be C. The heights of 25 individuals were recorded and the following statistics were calculated. The coefficient of variation will be. So I'm giving you the mean, the mode, the range, and the variance. Once again, variance, S squared is equal to 900. I'm looking for the coefficient of variation. This is S over X bar times 100%. I do have the mean. I'm missing the standard deviation. The standard deviation I can find because I have the variance. So from here, S will be equal to the square root of the variance, square root of 900, which is equal to 30. So you go back to your formula, you plug in the numbers, 30 over 60 times 100%, and this would be 50%. So the correct answer is C. The first quartile is the same as the 25th percentile. The interquartile range is the difference between the third quartile and the first quartile. The interquartile range is used to overcome what difficulty of the range? Remember when we said that the range gets influenced too much by outliers, something that does not hold true for the interquartile range. So the correct answer will be C. The range is influenced too much by extreme values. 14, the number of standard deviations that a value is above or below the mean. This is the definition of a z-score, of the z-score. The empirical rule says that approximately what percentage of the values would be within 2 standard deviations of the mean in a bell-shaped set of data. So the correct answer will be 95%. The variance of a sample of 81 observations equals to 49. The standard deviation of the sample equals to what? Once again, this is a question where you need to know your symbols. I'm giving you the variance. So S squared is equal to 49. I'm asking for the standard deviation. How do I find the standard deviation? I simply take the square root of the variance, square root of 49, so the correct answer will be C, 7. Let's look at the problems now. For the first one, the SAT scores of 10 students are given below, so you know that n is equal to 10. You want to calculate the mean of the sample, x bar. How am I going to find x bar? I will add all the entries. And I will divide by the number of entries that I have in the data set, which in this case is 10. So the mean is going to be 1100. So x bar is equal to 1100. For the median, this is the mean. For the median, as we mentioned before, first thing we do is we place the data in order. So let's write it down. So we place our data in order. We have an even number of entries. So we know that the median will be the average of the two middle values, ranked values. So in our case, 1060 plus 1120 divided by 2, 1090. These are your two middle values, therefore the median will be 1090. What is the mode? Once you place your data in order, you can see straight away if you have a mode. In this case, there's only one entry that occurs more than once, therefore the mode is equal to 940. The number of children for 9 households are given below. You have your data set. Once again, I'm asking for the 3 M's, mean, median, mode. We add them all. In this case, we have n equal to 9. To find the mean, you add them all, you divide by 9. X bar will be equal to 2. To calculate the median, you place your data in order, 0, 1, 1, 1, 2, 2, 3, 3, 5. I have an odd number of entries, so I know that the median will be the value in the middle, which happens to be 2. Mode, we see straight away we can tell that 1 is the entry that occurs the most often, so mode is equal to 1. Now, a private research organization studying families in various countries reported the following data for the amount of time 4-year-old children spent alone with their fathers. So you have the different countries, and then you have the amount of time spent with the children. Calculate the sample variance. So to calculate the sample variance, we write down the formula. S squared is equal to the sum of the squared entries minus the sum of the entries squared over n, and all of this over n minus 1. N in our case is equal to 5. We have 5 entries. So first thing we do is we need to find the sum of all the squared entries, and then the sum of all the entries. So the sum of all the square entries, you will do 60 squared plus 45 squared plus 55 squared plus 50 squared plus 40 squared. And then we will do 60 plus 45 plus 55 plus 50 plus 40. if you do your calculations, the sum of the squared entries will be 12,750. The sum of the entries will be 250. So you go back to your formula. You take the sum of the squared entries, 12,750, minus the sum of all the entries, which is 250. You square it. You divide by the number of entries, which is 5, and then you divide by 4. N minus 1. 5 minus 1, 4. So your answer for the variance will be 62.5. Calculate the sample standard deviation. Once you have the variance, this is very, very simple. For the standard deviation, all you need to do is take the square root of your variance, which means in our case the square root of 62.5, and this is going to be 7.906. Calculate the coefficient of variation. Coefficient of variation, to do so we need S over X bar. X bar, we find it by taking the sum of the entries, 250, over the number of entries that I have, 5, so this is going to be equal to 50. So 7.906 over 50 times 100%. 15.81% for the coefficient of variation. Problem number 4. A researcher has collected the following sample data. Calculate the sample variance, the sample standard deviation once again, and the coefficient of variation. So we repeat the same process for a different data set. To find the sample variance, this is your S squared. We write down once again our formula. That's the first thing that you want to do. And then you start calculating each component. So the sum of the squared entries, 7 squared plus 9 squared plus all the way to the end, 10 squared. The sum of entries, you simply add all the entries in your data set. The sum of the squared entries will be 532. The sum of the entries will be 64. We plug in the numbers in our formula. 532 minus 64 squared over, how many entries do I have in our sample size? N is equal to 8. 8 minus 1, 7. So the sample variance will be equal to 2.856. 2.856. To find the sample standard deviation, once again, all I need to do is take the square root of the variance, square root of 2.856, and this is going to be equal to 1.69. For the coefficient of variation, I need the sample standard deviation and the average. I don't have the average, but I can certainly figure it out. The sum of the entries is 64. I have 8 entries, therefore the average is 8. So 1.69 over 8 times 100%, and this will be equal to 21.13% for the coefficient of variation. Problem number 5. The hourly wages of 10 individuals is given below. That means that N is equal to 10. We start from there. We have the hourly rate for each individual, and the first thing I want to do is calculate the 60th percentile. Before you start with anything, since you're looking for percentiles, you need to place your data in order. So we place the data in order: 10, 12, 14, 16, 17, 19, 20, 22, 25, 27. I'm looking for the 60th percentile. I need to calculate index I. 60 over 100 times 10. This is going to be equal to 6. Since we have an integer, we will need to take the average of 6th and 7th ranked observation. 6th and 7th ranked observation, which means this is going to be 19 plus 20 divided by 2, 19.5 for the 60th percentile. So I need to find next the 80th percentile, P80. We calculate I, 80 over 100 times 10. This is 8. Once again, I will need to take the average of 8, excuse me, and 9th, 8th and 9th ranked observation. So the 80th percentile will be 22 plus 25 divided by 2, 23.5. 80th and 8th and 9th ranked observation, 22 and 25. I take the average of the two. Calculate the first quartile. Calculate the first quartile. What am I looking for? I'm looking for Q1. We've mentioned before, Q1 is P25, which means I 25 over 100 times 10, 2.5. I round up to 3, and I take the third ranked observation. What is the third ranked observation? 1, 2, 3, 14. So Q1 is 14. Q2, P50, median. I is equal to 50 over 100 times 10. 5, I need to take the average of the 5th and 6th ranked observation. 5th and 6th, 17 plus 19 divided by 2. This is equal to 18. Q3, P75. P75, I is equal to 75 over 100 times 10, and we have 7.5, which will turn into 8, and I will take the 8th ranked observation, which in our case is 22. IQR is equal to Q3 minus Q1, which means 22 minus 14 equal to 8. So the interquartile range is equal to 8. Now, for problem number 6, the mean life of a particular brand of light bulb is 1,000 hours, and the standard deviation is 50 hours. Tests show that the life of the bulb is approximately normally distributed. It can be concluded that approximately 68% of the bulb will last between which two values? The minute you see that you have normal distribution, bell-shaped distribution, you have the percentages, 68%, you will be using the empirical rule, which means that we have mu plus minus the number of standard deviations, right here, the number of z-scores times the standard deviation. So for 68%, this is going to be equal to 1,000 plus minus 1 standard deviation times 50, which is the standard deviation. So you will have from 950 to 1,050. So from here, you will do 1,000 minus 50 and 1,000 plus 50. This is how we got to these numbers. Jessica Salas, president of Salas Products, is reviewing the warranty policy for her company's new model of automobile batteries. Life test performed on a sample of 100 batteries. So that means that N is equal to 100, indicated an average life of 75, a standard deviation of 5, and that the battery life is approximately normally distributed. So for 95%, again, empirical rule. So you will have X bar plus minus how many standard deviations correspond to a 95%. This would be 2 and times the standard deviation. So this would be equal to 75 plus minus 10, which would mean from 65 to 85. Now, consider the following numbers: 40, 60, 70, 100, 110, and 190. What is the z-score for 70? Calculate the mean and the standard deviation. We will treat this as a sample size. First thing we do is we calculate the mean and the standard deviation. Since I'm looking for the z-score, X bar will be equal to 95. We add them all and we divide by the number of entries we have, which in this case is 6. So the average is 95. Next thing we do is we want to calculate the standard deviation. To find the standard deviation, once again, this is a sample. We take the square root of the sum of the square entries minus the sum of all the entries squared over n, and all of this over n minus 1. If you were to do the calculations, the sum of the squared entries would be 68,300 minus 570 squared over 6, and all of this over 5. Again, we take the square root, because I'm looking for the standard deviation. So this will be equal to 53.198. From these two, since I'm looking for the z-score, X minus X bar over S, X will be the 70, so 70 minus 95 over 53.198, and this would be equal to negative 0.47. So the z-score for 70 is negative 0.47, which would mean that 70 is 0.47 standard deviations below the mean. This is basically what we have calculated. Finally, for problem 9, the weights in pounds of 50 individuals were recorded and the following statistics were calculated. I'm giving you the following information. I'm looking for the coefficient of variation. S over X bar times 100%. Do I have X bar? Yes, I do. Do I have S? No, but I do have S squared, correct? The variance is S squared. From here, I can find S by taking the square root of the variance, square root of 900, which is equal to 30. So the coefficient of variation will be equal to 30 over 165 times 100%, and this will be equal to 18.5. 18%. So the coefficient of variation is 18.18%. Keep in mind that the coefficient of variation is always given in a percentage format. So this concludes the problems for chapter 3.